Okay, continuous compound interest. So we talked about compound interest yesterday or last time we were in class when we had the n equals however many times it took it each year. So if it was weekly, then n was 52. If it was monthly, then n was 12. Well, now we are continuously compounding the interest. So now we need to use this new formula, and I call this the PERT formula, kind of like the shampoo, if anybody's heard of PERT shampoo, where it's the principal. A is still the ending amount in the account. P is still the principal amount or the beginning amount. R still represents the rate expressed as a decimal, so turn the percent into a decimal by moving the decimal 2 spaces to the left. And T is still representing the number of years. So you don't need to re-memorize what all these letters mean or all these variables mean, because it's the same as when we did exponential growth and decay models. Okay, and when we did our compound interest when it was compounded not continuously. So continuously should be a red flag that you need to use this formula where we have E. So it's principal times E raised to the rate times T. That's both in the exponent spot. Okay, so if you need to pause to write this down, go ahead and do so. Okay, so you deposit $800 in an account that pays 6% annual interest compounded continuously. What is the balance after 3 years? So let's figure out our variables. So we know we have P, we have our R, and we have T. So take a moment and see if you can write in what those things are. So the principal should be $800. The rate was 6%, which changes to 0.06 because you take the decimal, move it to the left. That's how you do percents to a decimal. And then the time is going to be 3 years. So then we're just going to plug it into this formula, the PERT formula. So you're going to need to show your work, and basically you're just showing me what are you plugging into the calculator. So P is 800 times E, and in the exponent you should have both of these, 0.06 times 3. Okay, so let's go and practice plugging this in. Okay, so I'm back to my graphing calculator, and so we will type in 800 and then E, and mine goes up into the exponent in this spot. If yours doesn't, if it does the caret with the parentheses, you need to make sure you close your parentheses when you're finished. So then we type in 0.06 times 3. Okay, enter. So then $957.77 is what's going to be in your account. Okay, so let's go back. So then your final answer, make sure that they always have a label on it. This one's money. And so we said $957.77. So these will be worth 2 points. Again, if I say show your work, you're showing me what are you plugging into your calculator. You don't have to break it down this way. I just did that for this problem so you could see where all the pieces of the equation came from. Okay? All right, now we'll do the exit slip a little different. I want you to go ahead and try this, but nobody's going to come around and check it. So go ahead and pause this. Everybody try this problem, and then when you're ready, start it back up, and then we'll go over it. Okay, so you should have gotten this. So 4,000 is in the, you deposit that much, so that's our principal. Oops, you don't have to have that, I guess, for your E. And then we'll have E raised to this as a decimal, so 0.06. And this time it's over 2 years. And so if you plug that in, you should have gotten this approximately. Okay? So that concludes notes for 7.3. So go ahead and look at your assignment sheet and work on section 7.3 book assignment, which will be due tomorrow.